guys remember yesterday we did something that was pretty easy, right? I think you guys all understood it. I'm going to review it again because it's part of today's assignment. But this new part that we're doing today, you need to pay attention. It can be confusing at first, okay? And it's super, super important. We're going to be using it next week on something else that we learned, okay? So what we're talking about here is end behavior. And what that simply means is what is the ends of a graph doing? Like, you don't need to write this, but let me just give you an example of it visually. The end behavior of this line is down, up. Where am I getting down, up? The left side is going down towards negative infinity, and the right side is going up. It's like, what directions are the ends going? This would be up, up. I feel like we've talked about end behavior in here. We have talked about it. Yeah. As I'm teaching it to you, as I'm saying the words, I'm like, how do I feel about that? Well, that's what we're reviewing today. So that's great. So for those of you that remember it, you're in great shape. If you don't remember it, you're also in great shape because I'm going to go over it again. Okay? The direction a graph travels from left to right. From left to right. As we read a graph, always from left to right. Okay? Just like you read a book. Left to right. A sentence or page, whatever. Okay? So there are 4 different ones. And we're going to go through all of those again. And we get our end behavior from, okay, it comes from our leading coefficient and our degree, okay, which we talked about yesterday. So let's go over the 4 types and I'll explain what I mean. All right. If you have, and so especially since this will probably be easier than I thought it was going to be since we have covered it, have this in your notes so you can reference it, okay, if you get stuck. But you might remember it really well anyway. If the degree of a polynomial is even, okay? So degree is the biggest exponent. We talked about that yesterday. So you identify the degree and you decide, is it even or is it odd? Even is 2, 4, 6, 8, blah, blah, blah. Odd is 1, 3, 5, 7, and so on, okay? So if the degree is even, we could have, we then look at the leading coefficient. The leading coefficient can be positive or negative, right? Those are the 2 things that can happen with a leading coefficient. So degree and leading coefficient. And here's what would happen. If your degree is even and you have a leading coefficient that's positive, your graph goes up, up on the ends. And if it's negative, it goes down, down. I did. I told you I'm not on my game right now, guys. All right, sorry. Don't be mad at me. That's negative. No, you're not. So for example, if I had 4x to the 4th power, my end behavior would go up, up. Even number degree, positive leading coefficient. Okay? If I just make that 4 negative, it suddenly goes down, down. Yeah. So there's half of end behavior right there. And we just graphed a whole chapter of even degreed polynomials called quadratics, right? X to the second. Remember, if it was a positive, it opened up, and if it was negative, it opened down, right? And then the other possibility is if the degree is odd. And if you need to write, like, what, if it helps you to put some even numbers there, fine. You don't need to, that's fine too. But just remember which is which. So again, with the leading coefficient is positive versus negative. Okay. If it's positive, this is the one everyone messes up on. We think positive and we think it should go up first. It doesn't. It goes down first. Here's an example. Let's do 4x to the first power. That's a line. If it's a positive slope, like think about it. This is like y equals mx plus b. 4 would be your slope. It would rise as you go left to right. Right? That's a positive leading coefficient down up. So this one is the one I see the most mistakes on. We just hear positive and think it should go up first. It doesn't. And then negative 4x would just be the opposite. That's right. Just like a line with a negative slope. It would go like this. So it starts up. So these are the ones people confuse. Another, like a key word to help you is opposite. Odd and opposite both start with an O. And odd degreed polynomials have opposite end behavior. Okay? So you have to know this. This is important. Okay? You have to know it. So let's just do a couple examples, and then we will be able to just put it all together. Okay? So, any questions before I go to a couple examples? And show you exactly what your homework's going to be like. All right. So we're gonna state a whole bunch of things. State the degree, leading coefficient. This is from yesterday. Degree, leading coefficient, number of terms, and then the new part we're adding on is the end behavior. Okay. If it's not in standard form, you have to put it in standard form. I'm just not listing that. That's a given. We always put our polynomials in standard form. This is exactly what your homework's going to be like. Okay? This is the same directions for your homework. Let's just do a couple. While you guys are writing this down, just as a reminder, there is no Albert I.O. this week, but but there is one still available for half credit if you haven't done it. So the most recent one, you have till Monday at midnight to do it for half credit. I am going to have one more before Thanksgiving break, which is right around the corner, believe it or not. So I'll have another one available to you guys Monday. So, but there isn't one this week, so you wouldn't miss anything. Okay? And we're going to have one more quiz before break, too. So we're going to do 4.2 and 4.3 next week and have a quiz towards the end of the week. And that will get us to Thanksgiving. Okay, so guys, what's the degree? Degree. 3, right? It's the only exponent. It's the biggest, but the only. What's our leading coefficient? 5 or negative 5? Does it matter? Yes! That 5 and that negative are together. You can't break them up, Dylan. Don't even try. And then number of terms? Just 1. Negative 5x to the third is all one term. All one. Okay? Now let's talk about the end behavior. It's odd, right? This is where I go first. Odd, opposite. So I know it's either up, down, or down, up. And you either memorize or do what I do. Like I said, odd is just like a line. So if this was a negative 5x to the first, it would fall as we went left to right, like a negative slope, right? If I asked you guys to graph this, you'd have a y-intercept of 1 and a slope of negative 5 over 1, and your graph would go like this because it's negative. Same thing with all odds. So that would be up, down. And you could write the arrows. You could write up, down if you wanted to. I don't care. Either way. Good? Richard? Good? Kind of. Let's do another. G of x equals 3x squared plus 2x plus 5. Richard, do you know the degree? Yeah. Do you know the leading coefficient? I'm not trying to put you on the spot. Are you okay? I'm not trying. I used to hate that. I think I told you guys this. I used to hate it when teachers would call on me randomly. Like, what I was the student that chose the front of the classroom. I was a good student, but I didn't like talking in class. And so I hated being put on the spot. So I hate doing that to you guys. Okay, so, and the number of terms, 3, right? 3, 1, 2, 3. Right, that's what we did yesterday. Geo, I think you were the only one that wasn't here. This part, the end behavior, is the new stuff. So we find our degree. There she is. That's an even number. That means the end behavior is going to be the same, up, up, or down, down. And since it's positive 3, up, up. Let's just do one more. Wait a second. What is she writing up there? What is she doing? Why doesn't this one look like all the rest of them? Somebody, what am I doing with that? What was the reason I did that? Or what do we have to do? Foil. Guys, if you don't know what I mean when I say foil, please call me over to your desk when I'm done and I'm almost done. And that way I can explain it to you. Because I want to be able to say foil to you and you guys know what I mean. Because I keep going, do you guys know what I mean? And no one really answers me. So I just want to make sure. So we're going to multiply the 3x times everything the other set of parentheses. X your firsts and your outsides, F and O. So 3x times negative x squared would be negative 3x to the what? 3, right? 1 plus 2 is 3. Oh, I forgot, Brian, you weren't here yet. You did well on your test, though. 3x times negative 5 is negative 15x, right? Done with the 3x. Do the same exact thing with the 1. 1 times negative x squared is negative x squared. And 1 times negative 5 is negative 5. Now remember I said I didn't put it in the directions to put it in standard form, but if it's not, you need to put it in standard form. That's just a given, okay? That's like not going to be put in the directions. So x to the third, x to the second would come next, then our negative 15x minus 5. So standard form, combine all like terms, exponents in descending order. And then we can answer all the questions. Degree would be 3. Leading coefficient, negative 3. Remember, take that sign with it. Number of terms, 1, 2, 3, 4. And end behavior. Odd, opposite, negative. Okay, so we know it's going to be opposite because it's odd. Negative is just like a negative. Oh, we just had one. Sorry, I didn't mean to make another one the same way, but oh well. Okay, so that's up, down. A line with a negative slope. Okay. Okay. So for the guys that weren't here yesterday, we did rip out some pages. I just have to find that piece of paper to tell you what I ripped out. What we ripped out. I'll get back to you. But right away, it's 2:15. 17. We're on to page 217. We ripped out these 2:15. Okay, so on 2:15, you are doing 23 through 30. Okay, exactly what we just did. Okay, and my order might have changed a little bit. Oh, one more thing. Is it a polynomial or not? There's a yes or a no in there. And I color-coded it really nicely for you guys. So if you were here yesterday, I know you guys probably remember how to tell if it's a polynomial or not. The other people probably need to look at the notes. Okay. So remember our rules. To be a polynomial, you can't have a negative exponent. You can't have a fraction with a letter in the denominator. You can't have, what else? Can't have a radical under an x under a radical, and no fraction exponents. Those are the 4 things that prevent you from being a polynomial. That was in our notes yesterday. So, guys, don't copy my answers. Or if you do, I won't know it, but you'll know it on the quiz next week if you don't understand it. So please, try. This won't take you very long. There's no calculator work. You don't have to add, subtract, multiply, divide. None of it, really, except for the one that you have to FOIL. So really try to do it, understand it, and ask for help on anything you don't understand.